Okay, today let's talk about Codeforces round 986 problem D. First part is description. We are given an integer n, which means there are n type different cards. We are playing a game. We have a card of type 1 and we want to get a card of type n. We can exchange the card with other people. There are three people, Q, K, and J. There are three integer. That means their preference to exchange cards. For every people, for every integer, the every value, that means qi, means the value for I type cards. Every integer is a permutation of length I. That means every array is a permutation. That means every array is contain n distinct number from 1 to n. It is a permutation. In addition, every number of the array means the value for the current index type card. So for every people, he want to exchange a card which contain more value. For example, if the Q equal 5, 4, 1, 2, 3, that means he think the first card, the value of first card will be 5 and the value of second card is 4. So he preferred to exchange the second card with first card because first value is larger than the value of second. In addition, 5 is the most valuable card and the third will be the least valuable card among all cards. For the people Alice, that means this is Alice. He have a card of type 1 and he want to get the card of type n. The preference cards will be 1, 2, 3, 4, 5 till n. That means if Alice have a card 3, the card he can exchange will be 4, 5, and who is larger than 3. Yeah. That means the index of the card will be equal the value of the card for Alice. Okay, this is the description about this problem. Next part, let's talk about solution. For this part, actually we can check for Alice. We can check every card X from 1 to n. We can check it. The every type card which is accessible for Alice. That means for every card we need to check if Alice can get it from card 1 through exchange with other peoples. So actually for every card we have 2 steps to do it. First will be check if it is accessible. Second thing will be update the max value card. Actually it will be the max value for every person. This is what we need to do for every X. That means for X will be current card type. From 1 to n, we need to check if it is accessible from card 1 and update the max value for every position. Okay, we can do it. We can make the example. For example, Q will be 5, 4, 1, 2, 3. K will be 5, 1, 2, 3, 4. And last, J will be 1, 5, 4, 2, 3. Let's take this as this is a random example. First step, we will know we need to maintain the max value for every person. For the first card, okay, the max value, max Q will be 5, and max, okay, we need to change some value. We can change some value. It is not a great value. 2, 5. Okay. The max K will be 2, and max J will be 1. This is the max value. That means first time we have a card 1. So the max value for Q is 5. That means we can use card 1 to exchange another card whose value is less than 5 for people Q. In addition, for people K, we can use the card 1 to exchange a card whose value is less than 2 for people K. So this is the first step. We need to init the max value. So for the step 2, that means x equal 2. That means current index, current card type is 2. So first step, we need to check how to check the type 2 is accessible. That means we need, for every people, we can check the current value is less than the max value. If the current value is less than, that means we can use the last card to exchange the current card. Okay, for the first people, we found 4 people Q, we found 4 is less than 5. So we know it is accessible. It's accessible. That means we can get card 2. We can get card 2 from people Q. We can exchange it, use card 1. We can have a conclusion for the first step. That means this is accessible. After we know it is accessible, for second time, we need to update the max value. So for the max Q, the last max value is 5 and current is 4. So the max Q is still 5. For the max K, we will know the last max value is 2 and current is 1. So the max K is still 2. For the max J, we know the last value is 1 and current is 5. So we will know the max J will be 5, because 5 and 1, 5 is larger than 1. This is how we update the max value for every people. For the next step, x will be 3. That means we need to check card type 3. First step is check. For every people, we can check card 3 is a card. We can check if card 3, that means current card type, is accessible for current people. So for the people Q, we will know current value is 1 and max of Q is 5. That means we can get the type 3 card for people 1. Yeah, that means it is accessible. If it is accessible, we can update for every value. That means max Q, max K, max J. We can update one by one. This is how we do it. In addition, if it is not available, if it is not accessible, we don't need to update it. If the Q is not accessible, we can check K, we can check J, we can check one by one. We can check every people. If any person can help us to get current card type, this card type will be accessible. So until we found x equal n, till we check till we found card N is accessible. If it is, that means we can get card type N through card type 1. This is how we solve this problem. Okay. In addition, we accept the yes or no answer. We also need to output the exchange process. So we need to remember which card we to exchange current card. That means for every current card type, we need to remember which is the last card type which can help us to exchange the current type. This is the intermediate value we need to remember and store. So, but the strategy is what I said below. That means we have two steps to do. First is check, and second is update. Okay, this is the all solution about this problem. If you have any confusion, welcome to submit a comment. Next step, let's talk about complexity. For term complexity, we don't need a specific algorithm to solve this problem. This is a basic logical thinking problem. So, the term complexity will be O3 multiply n. And for space complexity, actually we need many integers to store the number, like the previous card we need to store to output the exchange process, and the position except the value for every card type for every people. We also need to exchange. We also to know the position for every card. So the space complexity also will be On. That means O3 plus n. Okay, this also will be n. So the space complexity and type complexity also be On. This is all about this problem. Thank you for watching.